So, let us take a look at the oldest one that we have in the conversational modeling. This is called ELIZA. As I mentioned earlier, this is from professor in MIT, Dr. Weizenbaum. So, he actually wrote a program that try to simulate methods used by a psychologist and then have an engaging conversation with the participants. So, what all he wrote was a set of regular expressions and then few modifiers, and then he created some templates and so on, and then very intelligently he coded the system, and then many participants had closed the door and then started having conversation with this engine, thinking that this was a psychologist. It responded in a human like fashion, but did not understand the query or conversation. Uses pattern matching with some rules like insertion, substitution and deletion, and no built in context understanding mechanism available as part of that. Okay, so, this was built in 1966. It is a set of rules that would do the insertion, substitution and deletion for what you said, and then maybe use a template and then modify the sentence that you had made in such a way that you would believe that the answering of your question is really coming after a thinking process. Okay. Okay, let us have a typical conversation that you would see on an ELIZA model. By the way, this is available as a Perl script for Linux boxes. I am not sure, I think if you have Perl in your Windows box as well, it would work. I have not tried it. It definitely works on the Linux box. It is available and you can install this application in about a few minutes and make it up and running, and you can have conversation of this type with that machine. Let us take some examples of what it outputs, by looking at the output. So, this is from the paper ELIZA, a computer program for the study of natural language communication between man and machine. It was published in January 1966 and the author is Weizenbaum. Okay. Here the bold ones, rather the capital and the text in yellow are from the machine, and this is input by a human. So, I have just copied some portions of what was available in this book and I present it here. Men are all alike. Maybe there are certain things that are before this. I am just starting from this sentence. Since the machine does not know how to respond, do any keyword modification or substitution and so on, there is a template available. So, it takes the template and then just pushes that. In what way? Okay. And then they are always bugging us about something or the other. Again, maybe it did not find the keyword that is part of the database. It says, can you think of a specific example? Okay. Well, my boyfriend made me come here. So, now look at this sentence modified by the ELIZA. My boyfriend made me come here. So, you see the transformation here, right? The my is moved in this way, and then me to you and so on. So, this is the kind of substitution and modification when it finds a keyword that is part of the ELIZA system. He says, I am depressed much of the time. Okay, and it probably knows that it is a negative connotation. So, it says I am sorry, again there is a template that kicks in, and I am depressed. You can look at this, right. This is changed to you are here. So, it is brilliantly done. Okay. So, without understanding any of the context, by just by looking at the sentence typed by the participant, this program makes changes in a way that it looks as if the machine is thinking and then responding to the questions or making some suggestions and so on. Okay. If you want to have fun with the system, try to implement this and try to have some kind of a conversation with this. Sometimes beyond a point it will start repeating the same sentence. So, I am giving all the examples, and then later based on the examples that we see, we also would like to pick up some important aspects of the examples and then see how those elements can be made available as part of the implementation. So, in the case of the ELIZA, it is about conversion of the text, right. So, or the substitution or trying to introduce some templates. So, that is what we learned from this. Let us take a look at the virtual agent from Microsoft. The source is available here. So, you can also have a conversation with this engine from this website. So, when you go to this website, it starts with a salutation, and then it will describe, it will say please describe your issue, I will look for the best solution. Okay. So, it is all related to Microsoft products. So, how do I find Office license key? So, it is a very general question. It could be for a Mac or it could be for a Windows machine. So, which one do you mean? How to find your Office product key, because look at the change here, right. So, it does not use the word license. So, it understands that the person who it is conversing with probably is looking at the product key and then not the license key, and this is the terminology it understands. So, it tries to force you to go into that direction, correct. How to activate or find product key for Office home use program? None of the above. So, I picked up the first one. I think that one is missing here. So, it says how to find the product key, and then it gives the response as follows: choose your Office version. So, now we are drilling down, and then the options are very limited, right. So, from the Office product key, from the license key, it was very broad. So, it is trying to narrow down and then trying to move you towards the path of the product key. So, we have come to the product, and then it says are you looking at the product key or activate or find the product key for home office use program. Okay, so, when I mentioned that I would like to find the Office product key, it says it gives you 3 options, or rather it gives you 1, 2, 3, 4, 5 options, and then it asks you to pick up one, right. And then you select Office 2011 for Mac. Okay, and then it asks the question, would you like to find your key or did you lose the key, right. So, you mentioned that I would like to find the key, then it comes. So, it starts slowly narrowing down the options for you, so that you can pick the choices provided by the system. So, it is more or less like a multiple choice question posted in front of you, but the context is coming from every question that you are responding to, correct. So, this is one example. So, in this case what we are learning. So, you first try to find out what the question is all about. Okay. And then if the question that you are posing does not have any key, and then try to find out the similar one that you can find in the set of answers you have in the corpus, and that is what happens here, right. Because the agent only knows about that. So, it does not know license, it knows that license could be equivalent to product and then starts from there. So, it narrows down the searches into the product space here, and then slowly it brings down or rather filters down the options, so that you would be able to pick any one of those, and then finally it gives you how to find the product key for your Office Mac version. Okay. So, this is the Microsoft Virtual Agent, and we have learnt a few tricks from here. Then let us go to the Google search box. I am sure this is very familiar to every one of us. So, when the Google or the Yahoo started, it is all about listing the documents based on certain ranks, right. Over the years you see that Google has improved the search mechanism and started providing some kind of a snippet for the keywords that you provide as part of the search box here. So, here what I did was I just provided 2 keywords and then put a question mark at the end, a Turing test with a question mark. It gave me a snippet, right, instead of providing the list of documents or the links that you normally provide, that you normally find, right. So, this is an interesting change. It is no longer about only providing the list of documents based on the page rank. It is now trying to provide certain snippets. The person probably is interested in the definition of this. So, let me first bring him the definition, and then later give him all the list of documents as part of the query. And then it is also interesting to find out that people also ask what passed the Turing test. So, these are all the questions posed by the user, okay, and then based on how many times certain questions are asked, it is trying to list those. So, how nice is it, right. So, in this case what is that we have learned. So, when the query is asked, it is no longer about the retrieval, it is about really finding the answer. By doing this, it is also saving time for you, right. So, that is the idea. So, try to understand what the query is all about. Is there a question in it? Is there a what question in it, or if there is a who, and depending on the query string, probably it is able to retrieve the relevant snippets for you, so that you save some time in terms of going through various links. Okay. There are 2 things that you find here. One is about the snippets, and then maybe we can call it as popular question. So, it is also suggesting, right. So, there is also a suggestion in terms of question. So, this would be very helpful if your question is not phrased very well. Okay. And then at the bottom you still have all the regular links for various documents. Okay. Now, let us look at the Jeopardy a game at a very high level. I am not going to be getting into the details of how Jeopardy is played. It is an interesting game where clues are given in the form of answers, and the participants are supposed to phrase the response in the form of a question. So, they can pick up any of the topic and then pick some dollar amount and then start responding to those queries, right. So, let us not get into the game part of that, let us see what is done internally, especially from the IBM Watson side, and then how they were able to create an application that competed with a human expert in this game. So, in this architecture, what you will find is you have lot of answers. You have a question, you start with a question always, right, and then there are lot of topics that are asked as part of the JEOPARDY game, and then there is a decomposition that you have to make. You need to understand whether what type of question it is, and then you generate various hypotheses based on the question. You have answer sources which are available in the form of text in various corpora, and then based on the question you should be able to pick up the evidence, okay, and then there could be multiple answers to those, okay, for the same set of question and topic. So, how do you rank them? So, you have some kind of a deep evidence scoring mechanism, and then finally provide answers to the question that you fix. For example, in this case, if the machine picks up notable women $400 and there will be a clue available in the form of the answer, immediately the machine should be able to go find out the question, analyze that, and then look at all the answer sources, and then pick up the top 10 answers, and then based on some kind of an evidence scoring mechanism, pick up the single answer that could be the answer to the question posed there, and then finally answer with some confidence. So, it all has to happen within the matter of few seconds.